2. Here we go. All right. So, let's see. So today's rate law is okay. All right. So I'm just gonna write what I have here. A yield products. This would be unimolecular. Since A is the only reactant, as the concentration of A increases, the rate will increase. So that rate law would be rate equals K times the concentration of A to the first. Nothing new. If we had A plus B yields products, then the rate law would be K A times B, or we could have A plus A yields products, and that would be rate equals K times A squared. One thing I want to mention though, these here, so this one, and this one here, that would be your rate determining step in the mechanism. So out of the elementary steps, so if you're given a series of elementary steps like we just did, we had step 1, step 2, one of those steps occurs slower than the other. That's where the rate law comes from. So if your rate law was A times B, then the slowest step would have A and B in it. If your rate law was just A, then the slowest step would have just A as a reactant. If it was A squared, then the slowest step in that sequence would be A reacting with A. I'm going to give you an example, obviously, but the rate laws can be determined from the steps, but it has to be the slowest step. Okay, and I didn't write that, but that's called the rate determining. The slowest step is called rate determining. So I guess we can write that over here. Rate determining step, and that's the slowest step. And how do you know? It usually tells you. It tells you that this is a slow step, or it gives you the rates. So let's see here. Let's see if I have an example here I can do quickly with you. Oh, and I also want to add one more thing here. It's the slowest step. This would have the lowest K. So the rate constant would be the smallest number there, which makes sense, right? So if you had rate divided by A times B, or rate divided by A, or rate divided by A squared, the slower the rate, the smaller the rate, right? The smaller the number, that's the slowest. That would be the smallest K. That should make sense to you. That if the rate decreases, but the concentrations, if we use the same concentration with slower rates, then your K is going to decrease as well. All right, let's see. We talked about that. We talked about that. Okay. Two things here. Elementary steps must produce the overall balanced equation. Overall equation. Oh, I forgot the word balance, sorry. Elementary steps must produce the overall balanced equation. The rate law must be, how do I write this? Hold on. Must come from the slowest step, which is called the rate determining step. So when you're writing out a mechanism, or if you see or given elementary steps, the slowest one must match the rate law. That's what that means. And then the overall equation must be, you must be able to get that when you start canceling things out. All right? And that's part of the intermediate stuff we talked about earlier. So when you see steps in a reaction, these things must be satisfied. This must happen in the slowest, and then you must be able to get the overall. So let me give you an example here, and then we will do the lab. All right, so the decomposition of hydrogen peroxide. What's the reaction? Remember I wrote it the wrong way and couldn't figure out how to balance it. So what's the correct way to do it? H2O2. H2O plus O2. Gas, liquid, this is usually aqueous. Okay, how do we balance it? I'll just do it for you, 2, 2. Okay, so this is an example where the first step is the rate determining. So this is the first step is the rate determining step, RDS, rate determining step. Okay. All right. Experimentally, the rate law is rate equals K times H2O2 times I minus. So that is the rate law. So if this was an AP question, it says, given the following reaction, here's the rate law determined experimentally. Automatically, I'm going what? Why? Where's the I minus? Exactly. Okay. Here's your elementary steps. So here's your mechanism. First step, step number 1. H2O2 plus I minus yields H2O plus IO minus. Above that arrow, put K sub 1. That's the first rate constant. So each step has its own rate constant. Each step has its own rate. So number 1, there's your first rate constant, or your first step there. Step 2, you take H2O2, react it with IO minus, you get K2, and you get H2O plus O2 plus I minus. So there's something in there that I haven't taught you yet. So here's the AP question. Part A. Which step is the rate determining step? I already told you. There's the notes. But if this was a question. Which step is rate determining, and explain why. Justify your answer. Part B. List any intermediates. Part C. List any catalysts. Part D. Draw an energy profile for this. Let's do A. I'm just kind of doing this out loud to make the notes a little bit more interesting. I'm not going to write all this down. But why is step 1 the rate determining? How do you know? Based on what notes we just took. How do we know step 1 is the rate determining? Because, because I told you that, but the answer I'm looking for is what you would write on the test. You would say the rate law is rate equals K times H2O2 times I minus, and that's the two reactants to step 1. That's the answer. So the rate law always matches the rate determining step reactants. Always. That's how you figure it out in real life experimentally. It's the two reactants that react the slowest. That's how you get your rate law. Because remember, the slowest is what dictates the overall reaction. Like the car in front going slow. So this one is where you get the rate law. And that's the rate determining step. First step is the rate determining. Rate law, which is the rate determining. Rate determining, and that is the slowest step. Slowest step. So that's another question I could say. Which elementary step is the slowest? they would give you this information. They'd say, which step is the slowest? You would say number 1, because that's where the rate law is from. That means it's the rate determining, which means it's the slowest. Now, what if we were to start canceling things out? What do we have to cancel out? IO minus, is that an intermediate or a catalyst? Intermediate. It's formed early, consumed later. So IO minus, I'm running out of room, you can put it somewhere underneath there, but IO minus is the intermediate. IO minus is the intermediate. It's consumed later, it's formed early. It doesn't appear in the overall equation. That's an intermediate. You guys remember the elephant toothpaste? That's what this is. So what's I minus? The foam. Foam shooting out of the thing. Okay. What's the I minus? Catalyst. Catalysts are used, listen to the definition of a catalyst, right? Speeds up a reaction, lowers activation energy, but here's another way to explain it. Catalysts speed up a reaction by giving the reactants an alternative pathway to form products, but catalysts are never consumed. They're always present. So they're there in the beginning and they're there at the end. However, they don't appear in the overall because they cancel out. So I minus is a catalyst because it's in the beginning step and it's at the products at the last step. So I minus is a catalyst. So intermediates are formed and then consumed. The catalyst, they're used as a reactant in the beginning, and then you find them as a product at the end, but only in the elementary steps. They're not found in the overall equation. Neither one of them will be. And that's the trick on the AP. They will ask for catalysts and intermediates. You need to be able to figure out which one's which. Again, catalysts you'll always see with the reactant, and then you'll see it at the product at the end, but they will cancel out because of that, whereas intermediates, the opposite. They're in the products in the beginning, reactants at the end, then they cancel out. So they're opposites there. So if you understand what a catalyst does, you should remember that it's always going to be with the reactant. It's helping the reactant. So it's going to be here. And then at the end, it's still there. Catalysts are never used up. They just help. You can take them out at the end and reuse them. All right, so that's where a catalyst comes in. So that cancels. That cancels. You got 2 of these, so that's 2H2O2. Yields, you got 2 of those, 2H2O, and then you got 1 O2. So yes, these steps are correct because it matches the overall reaction. So again, AP test question, they would give you these, they give you the rate, or maybe not. They might give you these and say, what is the rate law? So you'd have to know that if they told you this was slower, there's so many different ways. We're going to do practice problems, but that's kind of the gist of everything you need to know in one example. Now, how could we sketch a potential energy diagram? Let's say hold on a second here. What would make sense? What would make sense? Let's say I drew it for you. Yeah. Why does that? Yeah, I can see actually different types of questions here. They might give you these as a multiple choice. They pick the one that matches this reaction. They'd have to give you energy, XO or endo. Let's say it's XO. Why would the peaks look like that? Why would the second peak be lower than the first peak? If we know the first step is rate determining, why is the second peak lower? I want you to label these. H2O2 and I minus. This is IO minus. This would be H2O2 plus IO minus there. And obviously your reactants would be H2O2 and then H2O and O2. Those are easy, I feel like. It's the middle that's confusing. Earl, you got an idea?
Would it be because this is slowest because it needs the most energy, so it takes the longest to get there?
Right, so you're saying why the first peak is higher?
Yeah.
Yeah, very good. So because this is the slowest step, that proves it needs more energy to react. So this here, that would be the slowest step, and then this one here would be faster. So to go from your intermediate to the top here takes less time. We already proved that. They said that. This is your rate determining. So we know that's going to take a lot longer, so it's going to be a bigger peak. So all of this ties into kind of one question. All of the stuff we talked about today can all be lumped into one question. Plus learning or taking rate law that we learned before and applying it to something new as well. So I'm not going to give you homework, but the next time you have homework, it's going to be practicing using this stuff. We're going to take a little bit more notes on this tomorrow. Believe it or not,